Every hydronic heating and cooling system is intended to transfer and move heat efficiently. One of the easiest ways to measure that efficiency is delta-T. Delta-T is simply the difference between supply and return water temperature. A high delta-T means a better heat transfer rate, and more heat moves throughout the system with every unit of water. Building conditions are constantly changing, from sun, occupancy, and equipment loads. Efficient systems transfer heat effectively throughout the day, regardless of those changing conditions. But in many campuses and buildings, delta-T begins to shrink. This is known as low delta-T syndrome. When delta-T is low, more water is required to provide the necessary heating or cooling. That means higher flow rates, more running equipment, increased pump energy, reduced system capacity, and higher operating costs. The system may still work, but with lower efficiency. So what causes low delta-T? Delta-T is created at the heating and cooling coils, the point where heat is transferred to or from the water. This can be at air handling units, fan coils, or terminal units. In many systems, flow through these coils is controlled by pressure-dependent valves. As conditions change throughout the day, those valves constantly reposition in response to the demand. But when one pressure-dependent valve changes position, pressure changes ripple throughout the system. Flow through other control valves and coils changes unintentionally. Other valves react in turn, again and again. The entire system is in a constant state of flux. This flow instability reduces heat transfer effectiveness and increases the required flow rate, ultimately delivering a lower delta-T. Mechanically pressure-independent DeltaPValves solve this problem by eliminating instability and providing precise flow control at each specific coil. No hunting, no cascading pressure fluctuations, and no artificial delta-T overrides. Just accurate flow control exactly where it's needed. Stable flow leads to better comfort and efficient heat transfer. Better heat transfer naturally delivers higher delta-T. And higher delta-T means lower flow rates, less running equipment, reduced pump energy, expanded system capacity, and lower operating costs, all while improving long-term system performance. The DeltaPValve from Flow Control Industries. Precise flow control, engineered to solve low delta-T.